Hi student, let's try to understand the battery student. Any battery actually it may have one or more than one cell connected in series or cell that we use as a source of electrical energy is basically a galvanic cell where the chemical energy of the redox reaction is converted into electrical energy. However, for the battery to be practical use, it should be reasonably light, compact, and its voltage should not vary appreciably during its use. There are mainly two types of batteries possible. That is, first one is the primary batteries. So, what is the primary batteries, students? In primary batteries, the reaction occur only once, and after over a period of time, battery becomes dead and cannot be reused again. The most familiar example of this type is the dry cell known as Lagrange cell after it discovered, which is used commonly in our transistors and clock. The cell consists of zinc container that also act as a node, and the cathode is carbon graphite rod surrounded by powerful magnesium dioxide and carbon. The space between the electrodes is filled by moist paste of ammonium chloride NH4Cl and zinc chloride ZnCl2. The electrode reaction are complex, but they can be written approximately as follow. So anode that is zinc is converting into Zn2 plus, and cathode that is MnO2, it is taking NH4 plus electron, so it is converting a MnOOH plus NH3. In the reaction of the cathode, at the cathode, magnesium is reduced to form plus 4 oxidation state to plus 3. Ammonia produced in the reaction from the complex with Zn2 plus to give Zn NH3 4 times 2 plus. The cell has potential nearly 1.5 volt. Second cell is their mercury cell. This is the suitable for the current device like hearing aids, watch, etc. Consists of zinc, mercury, amalgam as anode, and paste of HgO, and carbon as the cathode. The electrolyte is a paste of KOH and ZNO. The electrodes reaction for the cell are what student anode if you see ZnHg plus 2OH, so it is ZNO plus H2O plus 2 electron. Cathode HgO plus H2O plus 2 electron, Hg plus 2OH. So this is the overall reaction is represented by Zn Hg plus HgO converting into ZnO plus Hg. The cell potential is approximately 1.35 volt and remain constant during its life as the overall reaction does not involve any ions in surrounding solution, whose concentration can change during its lifetime. Now the secondary battery we have to see. A secondary cell after use can be recharged by passing current through it in the opposite direction so that it can be used again. A good secondary cell can undergo a large number of discharging and charging cycle. The most important secondary cell is the lead storage battery commonly used in automobiles and inverter. It consists of lead anode and grid of lead packed with the lead dioxide PbO2 as cathode. A 38% solution of sulfuric acid is used as an electrolyte. The cell reaction when the battery is in used are given below. Anode, what is happening? Pb plus SO4 2 minus. It is converting into PbSO4 plus 2 electron. Cathode, if you see, PbO2 plus SO4 2 minus plus 4H plus 2 electron, PbSO4 plus 2H2. Overall cell reaction consisting of cathode and anode reaction. Pb plus PbO2, it will plus 2H2SO4, it will give 2PbSO4 plus 2H2O. On charging the battery, the reaction is reverse and PbSO4 on anode and cathode converted into Pb and PbO2 respectively. Another important secondary cell in the nickel cadmium cell which has longer life than the lead storage cell but more expensive to manufacture. We shall not go into detail of working of this cell and the electrodes reaction during the charging and discharging. The overall reaction during this one, cadmium plus NiOH thrice, it will give CDO plus 2 NiOH twice plus H2O. Fuel cell, this we are going in detail. Production of electricity by thermal plant is not very efficient method and major source of pollution. In such plant, the chemical energy, heat of combustion of fossil fuel, coal, gas or oil is first used for converting water into high pressure steam. This is then used to run a turbine to produce electricity. We know that a galvanic cell directly converts chemical energy into electricity and is highly efficient. It is now possible to make such cell in which reactants are fed continuously to electrodes and products are removed continuously from the electrolyte compartment. Galvanic cell designed to convert the energy of combustion of fuel like hydrogen, methane, and methanol, etc., directly into electrical energy or called fuel cell. Okay, so from the combustion, it is going to convert into the electrical energy. Now you see, one of the most successful fuel cell used the reaction of hydrogen with oxygen to form water. The cell was used for providing electrical power in the Apollo space program. The water vapor produced during the reaction were condensed and added to the drinking water supply for the astronaut. In the cell, hydrogen and oxygen are pure bubbles through the porous carbon electrode into the concentrated aqueous sodium hydroxide solution. Catalysts like finely divided platinum or palladium metal are incorporated into the electrode for increasing the rate of electrodes reaction. The electrode reaction are given by, so cathode, if you see, O2 plus 2H2O 4 electron 4OH minus 2H2 plus 4OH minus 4H2O plus 4 electron. Overall reaction 2H2 plus O2 2H2O. The cell run continuously as long as reactants are supplied. Fuel cell produce electricity with an efficient of about 70% compared to the thermal plant whose efficiency is about 40%. There has been tremendous progress in the development of new electrodes material, better catalyst and electrolyte for increasing the efficiency of fuel cell. These have been used in automobile on experiment basis. Fuel cell are pollution free and in view of their future importance, a variety of fuel cell have been fabricated and tried. Now we are going to deal with the corrosion. So corrosion slowly coats the surface of metallic object with the oxide or other salt of the metal. The rusting of iron, tarnishing of silver, development of the green coating on copper and bronze are some of the example of corrosion. It causes enormous damage to building, bridge, ship, to all object made up of metals, especially that of iron. We lose crores of rupees every year on account of corrosion. In corrosion, a metal oxidized by loss of electron to oxygen and formation of oxide. Corrosion of iron, commonly known as rusting, occur in presence of water and air. The chemistry of corrosion is quite complex, but it may be considered essentially as a electrochemical phenomena. At a particular spot of the object made up of iron oxide takes place, that spot behaves as a node and we can write the reaction 2Fe plus 2Fe2 plus 4 electron. This is the voltage, the SRP value minus 0.44. Electron released to at anodic spot move through the metal and go to another spot to metal reduce oxygen in presence of H plus, which is believed to be available from H2CO3 formed due to the dissolution of carbon dioxide from air into water. Hydrogen ion in water may also be available due to dissolution of other acidic oxide from the atmosphere. This spot we have cathode with the reactions. Now, cathode O2 plus 4H plus 4 electron 2H2O. This is giving the overall reactions 2Fe plus O2, 4H plus 2Fe2 plus 2H2O. The ferrous ion further oxidized by atmospheric oxygen to give ferric ion, which comes out as rust in the form of hydrated ferric oxide Fe2O3 dot XH2O, and with the further production of hydrogen ion. Prevention of corrosion is primary importance. It not only serves money but also help in preventing accidents such as the bridge collapse or failure of the key component due to corrosion. One of the simplest method of preventing corrosion is to prevent the surface of the metallic object to come in contact with atmosphere. This can be done by covering the surface with the paint or by some chemical. Another simple method is to over the surface by other metals, SN, ZN, etc., that are inert to rest save the object. An electrochemical method is the provide a sacrificial electrode of another metal like magnesium zinc etc. with corrode itself but save the object. So this is our required answer. Thank you very much for watching, dear students.